Okay, continuation of your mock paper, which was the November 2018, and this is paper 3, questions 10 to 14 or 15. We'll see how far we get. Okay, so I need a calculator for this one. So this is a function notation question, but it's just an instruction. So it says 4 sine of x, and that's what you do to the x. That's how they've defined this function f. Find f of 23. So what they've done is instead of the x, they've written 23. So the 23 is going to go in there instead of the x. So we need to say f of 23 is equal to 4 sine, and when x is 23, 4 sine 23. So let's get that done on our calculator. 4 sine of 23. 1.5629 ... Let's round that again, so it's got to be roughly the same size, but then we're going to say 1, 2, 3 significant figures. So that's where the wall's going, and the 2 can't see over the wall. So 1.56. Okay, and that was enough for the mark, that's correct. On to the next one. So this one, given me a different function, and now I've got to do f of g of x. And the way we've talked about that is you've got to put the g of x inside of f of x. So this one would be 4 sine of 2x minus 3. So then we're going to put 34 into this. So 4 sine of 2 lots of 34, take away 3. So I'm going to go back and edit my line here. I think I'm just going to put it in as it is. 2 lots of 34 brackets, take away 3, close brackets, gives us 3.625. Again to 3 significant figures, so there's our 3 figures, 1, 2, 3. There's where we're looking, and the 5 can see over, so it's going to be 3.63. The marks for that were 1 for a complete method, 1 for a complete method, so there's the complete method there, and a second one for the correct answer. Now they're introducing a third function. H of x is take the number, add 4 to it, and then square your answer. Ivan needs to solve this one here. He writes that the function would be equal to 25. That's good. That one seems correct. So it's set up correctly. It's just what he does after that. This is not fully correct. Explain why. Not fully correct. Explain why. So clearly he's made one error there. Now you can say square root both sides, but if you do that, you need to have a plus or a minus. I would say the safest way to do it would be to expand the brackets. That would give you, use your grid method again, that will give you, and either this way or that way will both show you that you end up with, so let's take away 25 both sides. That gives me x squared plus 8x minus 9 is equal to 0. And then you get, factorise it. I've got to make 9, so the obvious factors are 9 and 1. And if I go plus 9 and take away 1, that works. So I get these two solutions of x is equal to 1 or x is equal to minus 9. And you get the same here. You get, if you take away 4 from that, if this is a plus 5, you take away 4 from it, you get x is equal to 1. So that is correct, but he's lost a solution. So if you take away 4 from minus 5, you get minus 9. So explain why. Has lost a solution. Could have expanded the brackets. That's enough for the 1 mark there. Moving on. Okay, tan of x. This is the one with asymptotes. So effectively, you get lines going down like that. Now, if you're ever unsure about this, a thing to do is just put in values of tan. So try tan of 90 degrees, and that gives you an error. That shows you that the asymptote is there. And then if you do tan of 0, that's 0. So I know it starts there. And then it travels across and goes up, but it never reaches the asymptote. And then if I want to know, I can do tan of 91 degrees, for example, and that'll give me a big negative. So it comes up from there, comes across, and then it's going to do the same at 270. So you can do this in an exam if you've forgotten the shape of any graph. And then it does the same thing again, comes through like so. The 2 marks there are for a correct sketch and for asymptotes at 90 and 270. So mark 2 and mark 1. Okay, next question. We've got a pyramid with a square base, and they've told me here that AB is 5 meters. Now hang on, if that's 5 meters, surely that's 5 meters, and that's 5 meters, and that's 5 meters. Okay, the vertex is a posh word for corner. The vertex T is 12 meters vertically above the midpoint. So going up there, they're saying is 12 meters above the midpoint of AC. So AC comes through like that, and the middle of it, midpoint means middle, is 12 meters above. Calculate the size of TAC. So we've got T then we've got A and C. So it's that one there. Okay, so the first thing I'm going to do here is I'm going to take out a shape from the bottom of that there. Now, because this is a square, I could have put this on beforehand, but all of those are right angles. The ones on the base. We're not interested in the base one in the end, but let's take out that triangle, which is A, B, C. So you can see it there. So it's got a right angle in the corner because it's a square base. It's got a 5 meters there, 5 meters there. And if I can work out the length of the diagonal, I can half it and get another right angle triangle in there. So this is 5 squared plus 5 squared is equal to the hypotenuse squared. So that's 25 and 25 plus 25 is equal to that h squared. So that's 50 h squared. And when you square root, you normally have a plus or a minus, but this time we're going to have just a plus because it's a length. You can't have a negative length. So that gives me square root of 50. And I might leave it like that for a minute. Or I might turn it into a decimal. Very much your choice, but I suspect you lot would rather have a decimal. So root 50 is equal to 5 root 2 and 7.071 and I think that's probably just about enough for the moment, but I'm going to keep that in my calculator. So I now want to take out this other triangle A. We haven't got a letter for this, have we? But if I call it M, AMT. So I'm going to draw it again, make it as simple as possible so that on an exam day I'm not having to hold lots of numbers in my head. ATM. So AM is equal to half of H. So let's divide this by 2. And that gives me 3.5355 ... So I now know this is 3.5 ... and I also know this is 12, and I've got to work out the red angle you can see there, the angle TAM or ATM, or MAT, maybe I should have done. So that's equal to, let's have a little look. So if this is the angle, this is the opposite. Now there's a right angle there because it's come straight down. This means there's a right angle in there because it's come vertically, and vertical to horizontal must be a right angle. This is adjacent, and this is the height. So I need my SOHCAHTOA again. SOHCAHTOA. And which one do I want? I want the one with opposite and adjacent in it. Opposite and adjacent. It's tan of an angle. In fact, I might rewrite this bit. Tan of an angle is equal to opposite over adjacent. And I don't know what the angle is this time, but I know the opposite and the adjacent. That's 12 divided by my previous answer, 3.5 ... To undo the tan bit, I'm going to say theta is equal to tan to the minus 1 of that 12.35 ... Okay, So how do you undo the tan? You do tan to the -1 of the other side. So let's type that in. I'm not going to press clear, and I need to get out of that habit. I'm going to write down. I want tan to the -1, so that's second F and tan, and then I've got brackets 12, and I want to divide that by the previous answer, so that's that alpha answer. Close brackets, gives me my answer of 73. Let's just see. Doesn't tell me how accurate to be on this. 73.58. Let's just double check that that's correct. 73.58, yeah, they want 73.6. So first job is you had to get to that stage for your first process mark. Your next process mark was for finding a length for halving that, to get that bit. And then you got a mark for using the correct trigonometry, and a final and accuracy mark there as well. Okay, on to question 13. So I think one of the things to remember is that this paper was quite a lot easier than the other two. And if the first two papers, or the first paper, is difficult, to hold on and just really keep your composure, because there are things you can do here. So the number of animals in the population at the start of the year, T is PT. The number of animals, so that's at the start of the year. So this will be the start of the next year, because it's PT plus 1. Work out the number of animals at the start of year 3. So what we need to do for this is to work out the population of year 2. We need to do 1.01 times the population of the first year, which is 400. Pretty easy to do this. So they've given you the instruction, all you've got to do is use it. It's a little bit like now the new amount goes in to the same thing. So P of, at the beginning of year 3, so remember this is at the start of the year, and we want start of year 3. Okay, so this is the one we want. So 1.01 this time times 4.04. So again, I can go back and edit my line for speed. And it gives me 408.04. They've rounded that ever so slightly, but you get the mark. You definitely get the mark for that. It says it's a correct answer, and you get a mark for this process here. So this topic is called iteration. It's a good topic to revise because it's fairly easy. It's just following instruction repeatedly. Iteration. Right, onto the one at the bottom. Another good one to revise. Proportion. So here we get y is inversely proportional to x cubed. Sometimes you get a mark for that. You definitely get a mark for this bit. So this is timesing that previous one by a constant. So it's the same, just multiplied by a constant. And we want to work out what this multiplier is, which completes the formula. So substitute in the values they've given us. In fact, slow down, let's just read the question. So the key word there was inversely, that's why we did 1 over. And be careful to get x cubed in there. So now we've got these two. And this is a standard format question, so you can drill this and get it right every time. These are going to be substituted in, and they're going to complete our formula, and then we'll use our formula for to show something. Now it doesn't matter to us that this is not strictly a number, because we can we'll just carry on a normal process and it'll be fine. So put in the 44, and this time we're going to have k on the top, and on the bottom we'll end up with x is going to be a, so it'll be a cubed. So k is going to be equal to, well, to get this a off the bottom, I'm going to, because that's divide by a cubed, I'm going to times by a cubed. So I'll get 44a cubed is equal to k. So I can stick that back in my formula instead of that. So I've now got my formula being y is equal to 44a cubed over x cubed. Now I'm going to use this information and put that into it. So I've got y is equal to, and y this time is 5.5, substitute it in, and it's still going to be a cubed, but now they've just told me that is 2a, x is 2a, but I remember I've got to cube it. So let's continue working here. And in fact, because this is a show that question, I'm not going to put the 55 in. I'm going to leave the 55 out and put the y there and see what happens with this. So I'm expecting it, when I've expanded it, to come out as 5.5. So if it doesn't, I've clearly done something wrong. So in this, it's 2 cubed times a cubed. Now that's 8. 2 cubed is 8. And